What do you mean by operators? The symbols. So the answer is very simple. Answer is the symbols that trigger the operation or action on data are called operators. And the data on which and so there is another concept called operands, right? So what is an operand? What is an operands? Operands. What is operand? So answer will be for this one is the data on which the data on which operation is being carried out. Operation is being carried out. That is the objects of the operations. The objects of the operations. Operations are referred to referred to as operands. As operands. Fine. Please be muted. Don't unmute yourself. So, so that is an operands. Fine. So data on which operation is being carried out, that is the objects of operations are referred to as operands. Fine. So, so if we perform, say for example, if we perform an operation like say 10 plus 20, right? So this 10 and this 20 is operand, and this plus is an operator, and they are the whole thing is called operation. Operation, right? So here in this example we are performing one addition addition operation. Fine. So Python is very op, rich in set of operators, right? So it has many operators. Okay. So Python's Python's rich set of operators comprises of comprises of these types of operators. Types of operators. So number one is arithmetic operators. Arithmetic operators. Number two is relational operators, operators. Number three is identity operators, operators. Number four is logical operators, operators. Number five is bitwise operators, bitwise operators. And number six, we have membership operators, ship operators, operators. So I will try to teach you all types of operators in this class, right? And I will teach you membership operator in the future, right? Because the concept required for membership operator is not given in the previous classes, right? So this I will teach you later. So today I'm going to covering up arithmetic operators. I'm covering relational operators. I'm covering identity operators. I'm covering bitwise operator. I'm covering logical operators. Fine. So I will cover membership operators later on. All right. When I will teach you in detail regarding strings, list, dictionaries. After that, I will teach you in the same time. I will teach you the membership operators. If I teach you membership operators in this class, it will be very much difficult to understand, right? Logically, maybe few people have programming knowledge, they may understand, but there are few people they are doing programming for the first time, so they will not understand. So it's better to go with the public, the more public which is not knowing the programming, they are doing it for the first time. Okay, so it will be difficult for them. So let me teach you the basics first, and then we move to the advanced topics. Right. So first is arithmetic operators. Fine. So number one is arithmetic operators. So, so number one is arithmetic operators. Operators. So arithmetic operators are basically addition, subtraction, multiplication, right, and division. Right? This much everyone knows, right? So these are normal arithmetic operators which we have seen in our real life, right? And they do the similar kind of a task in Python also, right? Okay, but in Python also provide some special arithmetic operators like this double slash is actually floor division, right? Floor division, floor division, right? This this percentage sign is basically called a remainder, right? It will generate the remainder when you divide. And this double star is called exponentiation. Exponentiation symbols. So let me show you a few examples of these. Fine. So plus, so 10, if you write here 10 plus 20, it will definitely generate the result 30, right? Same thing happens with the minus thing also. If you write 10 minus 20, it will give you minus 10, right? If you write here 5 multiply by 5 multiply by say 4, it will give you 20, right? If you write 5 divided by 2, it will give you 2.5. So it's a normal things, right? Now let's talk about floor division, right? So floor division, basically if you write here 5 slash slash 2, right, it will give you 2, it will give you 2, right? So floor division is used to give quotient, right? Floor division will return you quotient, it will return you quotient, right? Basically it's always returning the quotient. Okay, if you write here 7 divided by 2, so, or you can take the bigger number like 77 divided by 77 divided by 23, right? I'm giving spaces to for the clarity. You can't give, you don't have to give space. Spaces are not compulsory over here. So you can't give space also, and you can try it, it will work. So I'm giving spaces for the clarity. So if you write 77 floor division 23, so what it will return? It's returning 3, right? So, so 77, if you divide 77 with 23, what it will do, right? So if you write here 77, if you write here 77, and if you divide it by 23, right? So 23 threes are is 69, right? So it's always returning the quotient, right? So 17 minus 9 is 8. So 8 is the remainder. So let us apply the remainder operator in the next example. So if you write here 77 modulus of 23, now you can see the result, it's returning 8, and which is the remainder, right? So next operator is exponential operator. Say for example 2 star star, you have written here 3. So it is returning 8. That means 2 to the power of 3. If you write 3 star star 4, it will return you 81, right? So this is basically an exponential operator. So it's returning exponential result, right? It works with both float and it works with both. It will works with float also. If you write here 2.5, okay, star star 4, it will work. So it's returning you 39.0625. Okay, so it works for float also. Okay, so I'm pasting all these examples over here, right? So examples of arithmetic operators. So the next operator is a unary operator, right? So this operator, unary operator, operators, right? The unary operators are basically the operators that acts on one operand, right? Unary operators that acts that act on one operand, that acts on one operand are referred to as unary operators. Unary operators. Fine. So there are two unary operator. One is unary plus, and number two is unary minus, right? So if you write here, if you write, say for example, if you write a is equal to 5, right? it means the value of A is positive. Fine. It means the value of A is positive. And here you have implemented plus 5, right? So if you write A is equal to minus 5, that means K, you are using unary minus. This is unary minus, right? So you can write this statement as this also, plus 5, right? But we won't write the plus symbol unnecessarily, right? You can write this also. It works in Python, right? So in this way, we can use the unary plus and unary minus operator. Okay. Acha, there is another thing I've forgotten to say by mistake, that all the arithmetic operators are binary operators. Binary operators, right? So binary operator basically means it always needs two operands, right? So binary operators always needs two operands, two operands. Fine. So all the arithmetic operators are binary operators. Okay. So the next thing is the thing is next thing is augmented assignment operators. Sorry, by mistake I took this pen. So the next thing is augmented 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 assignment operator. Assignment operators. Fine. So you have already know that Python has assignment operator, which is equal to symbol, right? Which assigns the value specified on the right hand side to the variable or object on the left hand side of equal to, right? Basically, we write something like this: x is equal to 5 plus y. So what it does, it assigns this result, this calculations result to this x, right? So this is left hand side, this is left hand side, and this is right hand side, right? So we all know mathematics, so this is very much obvious thing, right? So Python also offer augmented assignment arithmetic operators, right? Which combines the impact of the arithmetic operator with the assignment operator, right? So what I'm trying to say here that say for example, the value of x is say 2, and I want to update the value of x with 3. I want to update the value of x with 3. So what I can do here, if I can write it in this way, x is equal to x plus 3. So the value of x will be updated to 5. I can write it in this way, but Python has given another way, right? So if I write here x plus equal to 3, it means the same thing, right? So this kind of a situation is called augmented assignment operator. Augmented assignment operator. Augmented assignment operator. Fine. So this is how augmented assignment operator works, and we can use the augmented assignment operator. Means all the operators can be augmented with the equal to symbol, right? Say for example, you have you can write it like this. x plus equal to y, right? So what does this means? This means x is equal to x plus y, right? You can write something like this, x minus equal to y. This means x equal to x minus y. You can write x multiplication equal to y. So this means x is equal to x multiplied by y. You can write here x, okay, I've covered the multiplication. You can write here x divided by equal to y. So this means x is equal to x divided by y. If you write here x floor division equal to y, so that is equal to x floor division y. Fine. So in this way, you can write the augmented operators. You can write here x modulus equal to y. Okay, so that will be equal to x is equal to x modulus of y. Fine. So these operators can be used anywhere that ordinary assignment is used. Augmented assignment doesn't violate mutability, right? Therefore, x plus y creates an entirely new object x with the value x plus y, right? So I have covered the mutability concept in the previous videos. So if you have any doubt, you can go to YouTube and see the previous video where I have covered the mutability. All right. So next thing is so next operator is a relational operator. I hope augmented assignment operator idea is clear, right? So there is another thing regarding augmented assignment operator is that this operator can be used with the bitwise operators also, right? So augmented assignment operator can be used can be used with bitwise bitwise operators. So when I will teach you bitwise, then I will teach you how to use augmented assignment operator. Fine. So it can be written it like this, x. So this is bitwise or equal to y. So this will be written like this, x equal to x or y. You can write it like this, x and equal to y. So it will be written like this, x equal to x ampersand of y. So these are bitwise operators, right? And these bitwise operators I will cover. Don't worry, I will cover it when I will teach you. There are bitwise operators like and, or, not, fine, XOR. So these kind of bitwise operators you can use it. Okay. So let me write it over here, but I will give you the explanation when I will teach you the bitwise operator. Because first you need to know how bitwise operator is being used in the code, right? And then you can apply it. So this is like this, x. So it will be like I've written this is or, this is and. So let me write XOR equal to y, and you can write here x. Then this is a tilde sign equal to y. So this means complement, right? So this is equal to x x or y, and this implies to x equal to x complement of y, x complement of y. So wait, complement operator can't be used like this. We can use this because complement operator is basically unary operator. So we cannot use it like this. So we can, if we have to use complement operator, then we have to use it like this. Okay, x equal to complement of y, right? So complement operator is another example of unary operator. Unary operators. Actually, I'm trying to cover up the basics of the operators, so sometimes I may miss out something. So I will explain it in between the topic. This is another unary operator, and it needs only one operand. So it will not work with the augmented assignment operator, because augmented assignment operator works with binary operators, right? It only works with the binary operators. Fine. So the next thing is relational operators, right? So let me write it here. Relational operators. So let's get rid of the screen and write relational. So we write it here. Relational operators. So relational operators, we know that they used to so so they refers to the relationship that values can have with one another, right? So does the relational operator determine the relation among different operands, right? So the relational operators, the relational operators determine the relational operator determine the relation among different operands. The relation among different operands. Different operands, right? So Python have all the relational operators, right? And if there are many relational operators, like this is less than, this is less than, we have less than, equal to, less than, equal to, less than, equal to. Then we have equal to, that is equal to, right? It is used to compare for equality. Then we have greater than, then we have greater than, then we have greater than equal to, greater than equal to, greater than, or I've forgotten the word here, or equal to, or equal to. Then we have not equal to, then this is not equal to operator, right? So a relational operator work with nearly all types of data in Python, such as numbers, strings, lists, tuples, etc. Okay, so relational operators, relational operators work with nearly all types of data, all types of data in Python, in Python, such as numbers, such as numbers, such as numbers, string, string, strings, lists, list, and and tuples or tuples. etc. Okay. Relational operators work on the following principles. Okay. Relational operators works on following principles. Following principles. Right. So number one is, say, for numeric types, right? For numeric types, the value are compared. The value the values are compared after removing the trailing zeros. Compared after removing trailing zeros after after decimal decimal point from a floating point number. From a floating point number. Floating point number. For example, for example, say you have a number like 3.250, right? And it what will happen? What Python will do? Python will convert this as 3.25, right? And then it will compare, right? So Python will remove this zero. Python will remove this trailing zero, this trailing zero, and then then this value this value will take part in comparison. Will take part in comparison, right? So next concept is, okay. Next concept is strings are compared on the basis of lexicographical ordering, right? Strings are compared. Strings are compared on the basis of lexicographical lexicographical ordering. That is the ordering of dictionary. Ordering in dictionary. Dictionary, right? So here, capital letter considered, there is a concept out here. Uh, here means ki the comparison is done. There are some technical things right over here. So the technical things is called, say, the value of capital A internally in computer is 65, right? Capital B's value is 66, right? These values are called ASCII value or Unicode value, right? These values are called ASCII values or Unicode values, okay? And in this way, you can, if you traverse all the letters, if you reach capital Z, it will be 90, right? Small a value is 97, right? Small b is 98, 8 and so on. If you reach Z, it will be 122. Okay. So there, so these values are internally compared, right? So these values are internally compared, right? So lexicographical ordering, right? So we can say that lexicographical ordering, lexicographical ordering is implemented via the corresponding corresponding codes, right? Or ordinal values, ordinal values. So these ordinal values are called ASCII values. These are called ASCII values. These are called ASCII, ASCII values, ASCII or Unicode values Unicode values, right? So these values are called ASCII or Unicode code, right? Of characters being compared, of characters being compared, compared, right? So that is the reason. So that is the reason. That is the reason capital A is less than small a, less than small a, right? Because the value of capital A is what, 65, and the value of small a is 97, right? So you can check the ordinal code of the character by yourself also, right? Let me show, I will show you in the Python key how you can check it, right? So let me create some space so that I can paste my example. So let me show you. Say for example, if you write here ORD, if you write here ORD, so ORD is a method present in Python, and if you type here capital A in a string format, right? So if you type here, okay, and then press enter key, you can see the value here. It is 65. Okay. So same way, if you type B, if you type B, the value 66. So if you type here ORD Z, right, and see the value, it's 90. Okay. If you type ORD small a, the value 97. Okay. Similarly, you can, if you type here small b, you can see 98. If you type ORD of small z, right, you can see the value 122, right? So this is what I'm talking about. Okay. This is what I'm talking about over there. This is what I'm talking about over here. So you can see that the values I have written over here, A 65, B 66, then Z is 90 and small z is 122, right? Evenly the numbers also have the values like this. If you go here and if you type numbers instead of ABC, right? If you type here, so if you type here the numbers like 0, value of 0 is 48, right? Similarly, if you type here 1, so you'll get the value 49, right? So all these ordinal values are called Unicode value or ASCII value. Okay. So if you type here 9, If you type here 9, you can get 57. So we can take this example also. So these ordinal values in string is compared with the internal values of these things, right? According to the internal values, it works. So according to internal values, the string compares the matter. Fine. So for the same reason, you need to be careful about non-printing characters like spaces. Spaces are also the real character, right? If you type a space here, na, if you type a space here in the string, right? If you are not providing anything, that means, oh, just a minute. So if you're typing here a space, I'm not typing anything. So the value of space is 32, right? So it has not given me, it is showing me invalid syntax, but the space is 32. I think I have given two spaces. Oh, you can see that. Okay, I have given two spaces, that is why it is showing me an error. But the value of space is 32. Okay, so the value of space is 32. And copied. Yeah. So the value of space is 32. Uh, it will because why these values are defined. First of all, you try to understand why these values are defined. Why these values are defined, right? So first you try to understand this, ki why a capital A is 65, why capital B is 66, Z is 90, right? So it helps in communication. It helps in it helps in communication. Communication, right? Say for example, I'm typing the data in Skype, right? I'm typing a message in Skype, right? I'm typing a message in Skype. Okay. And say I've written here how. Say for example, and it reaches to your machines. It reaches to your machines, right? It reaches to your machines, right? Say this person is sitting somewhere. Say I'm taking example. Say he is sitting in Bangalore. He is sitting in Udupi. He is sitting in Bangalore. Or he is sitting in Durgapur. Right? There can be many places this message is going, right? Fine. So you can so everyone can see in their terminal how, right? He is also see how, this person can also see how, this person will also see how, right? So the point is that K if and all these people are using different brands of computer, right? Say for example, this person is using Apple's computer, this person is using Apple's computer, this person is using Dell's computer, this person is using Lenovo's computer, this person is using any other company, HP's computer, right? So all the people are using different computers, different devices, but they are able to see the same messages, right? How it is possible? It is possible because all these values are standardized, right? All these values are standardized. So the manufacturer of the keyboard or the computer manufacturer has to follow the standards of Unicode or ASCII code, right? Such that when the communication will become easier between the devices, right? So that is why these values are defined. Fine. I hope everyone understood, right? Because when they are communicating, then I can also understand the message, right? So that is why these values are defined or standardized. So every computer manufacturer has to follow this standard. Okay, say for example, you are pressing A and it generates electrical signal, right? If you're pressing A, it generates electrical signal. Okay, and and in every device that signal may differ, right? So if you are following right a standard, then every device should generate a similar signals for A. So the 65 is not exactly stored inside the memory. The binary value of 65 is stored. The binary value of 65 is stored, right? So the binary value of 65 is 64 plus 1, which is 65. So this is the binary value of 65. So this value, so this value, this kind of a binary value is stored inside the memory when you press A. Fine. So whenever you are transferring your message from one device to another device, and or you are receiving a message from one device to another device, you can see the same kind of a characters, right? If character changes in between the communication, then you will get a different message, right? Then then the communication will differ, right? So for this, we have to follow some standardization, right? So this standard organization name is Unicode. The name of the standard organization is Unicode, right? Earlier it was ASCII. Earlier it was uh, ASCII. ASCII is basically one byte code, one byte code, and Unicode is now 2-byte code, right? That means that Unicode supports more symbols compared to ASCII. Okay. So I hope this idea is more or less clear, right? You see the videos again and again. You can easily understand this concept. It's not a difficult concept. It's basically made for communication. These values are made for communication, and these values are fixed also, right? These values are not going to change from computer to computer, right? So this is fixed in every computer. So you don't have to think about it. Okay. So this is basically a standard rule. Say for example, no, negatives. See one thing, Subbalakshmi is asking that it's working, it's going to work with the negative or not. Negative means that there are two symbols out there, Subbalakshmi. There are two symbols, right? There is one a symbol called minus. So minus has its own Unicode value. Minus is having own Unicode value, and the number you are using, that has his own Unicode value. And I have said that it is a fixed value, you cannot change it, right? I have said this is a fixed value, you cannot change it, right, with your own. Okay, so if you give minus in that part, it may give you some absurd results, right? So you can give a try also for minus ORD, and if you put here minus say 10, right, that will give you some result like this, right? So I've said that these values are fixed. Keyboards, every character is fixed, right? Other than that, Unicode supports it's actually multilingual kind of a thing. Okay, so it is a multilingual kind of a thing. So it supports multiple characters, like it supports a Bengali character, but I don't have a Bengali keyword. The people who are using Bengali software, they have their Bengali keyword, right? Bengali key in their keyboard. So if they press the combination of the keys, I don't know what is the combination of the keys. So that Bengali character will appear and it has its own value, right? They have defined it. Okay. So so you need a Bengali keyboard for that purpose. Fine. There are many Indian languages, many different languages are acceptable, right? Evenly in Python is also supports multilingual thing, right? In Python also you can generate outputs in Bengali, All right, it won't be a problem. But I don't understand the means ki proper alphabets in Bengali. So it's very difficult for me to generate, but I can show you the process. Okay. So we'll talk to these things later on. Fine. So let me focus on the topic. So, so this is the basic thing. Okay. So next thing is this K two lists and similarly two tuples are equal if they have same elements in the same order, right? There is another thing over here. Two lists. There is another point. Another point is two lists. Two lists. I will teach you what do you mean by lists and tuples also. Two lists and similarly two tuples are are equal if they have if they have same elements if they have same elements in the same order in the same order. Fine. The next thing is boolean true. Boolean true is equivalent to numeric 1 is equivalent to numeric 1. And boolean false and boolean false to 0 numeric 0 for comparison comparison purpose. Yes, purpose, right? So we can see a few things, few examples in Python over here. So for example, I'm writing here. Okay, let me store some values like a is equal to 3, comma b is equal to 30, comma is equal to 3.0, right? Oh, I can do this in Python. Let me do it over here. A, comma b, comma b is equal to 3, 13, 3.5 or 3.0. Oh, so I have stored these values, right? So let me compare. Okay. So if you write here A less than B, right? So what it will return? It will return you true. Okay. If you write C is less than D, no, I have used here what? C, I have not defined C here. I have defined here B. So if I've written here B is less than P, right? So it will return me false because the value of B is 13 and the value of P is 3. Okay, if I write here B is greater than A is greater than P, so it will return me true. It's returned me false. So B is greater than A. So B is greater than A So this is quite interesting. It has returned me false. Okay. So why it is returning me false? Control C. If we have this, this is quite interesting. Okay, it has returned me false. Okay. So what is happening over here? So you should just try to understand, right? When I have done chaining of operators, right? So B is less than P is returned me false. A is less than B is returned me true. Fine. It's very obvious that key the value of A is pointing to 3. The value of B is pointing to 13, and the value of P is pointing to 3.0. It is float, so it has a separate memory, right? Separate memory pointing thing, right? So if I'm writing here A is less than B, right? Then it's returning me true, it's fine. If I'm writing here B is less than P, it's fine. But when I'm returning this, okay, B is greater than A, right? And I have written here A is greater than P. So it is returning me false because the value of B is 3, 13. 13 is greater than 3. So result is true. So the result is true. And and true means what? True means 1. True means 1. 1 is greater than P. Answer is 1 is greater than P. So what is the value of P? P is 3.0, right? So answer is false, right? So true and false and false will make false, will make false, right? Understood. So we can chain the operators, right? And we study about chaining of operators in Python, right? In Python, we can do chaining of operators, right? So this concept is called chaining of operators. I will invest time on chaining of operators in Python. It's very much interesting. Fine. So you should understand these concept in Python. Fine. So let me do few more examples of comparisons. Say for example, let me write here C, comma D, comma E is equal to. So here I have entered N. Here I have entered G, and here I have entered E. I can store the value C, D, E. Now if I write here C is less than D, right? So the value of C is N and the value of D is G. So it will return me false, right? Because the value of C is N, which comes after G, right? So it has a greater ordinal value. So it will return me false. Fine. So let me take few examples like this case D is greater than E. So what it will return? Just type it on your chat window what it will return. The value of D, the value of D is G, right? The value of D is G and the value of E is E, right? So what it will return? So how many people have said false? Oh, okay. So it's rectified. Fine. So it is going to return true. Fine. So if I write here something like this, okay, Let me write a few more examples. Say f g h equal to is equal to God. And let me put here God g god God. And we can write this as gh God, God and God. If you write here f equal to h, what it will return? True, true, true. So it will return true, right? Because both the values are same, right? Because both the variables are pointing to the same memory location where God is stored, right? So, but if I write here f is less than g, right? What this will return? Please type in your chat window what this will return. Oh, the value of f is a small god, right? And the value of h is god, right? So both are equal, so it will return false, right? Okay. So be cautious when you are doing comparison. Okay. So if I have written here, if f, no, sorry, f and g I have compared. Sorry, by mistake. So the value of f is small g and the value of God's g is capital. So small g is greater than the capital G, right? This, yeah, it's not equal. It's not equal. So small g is greater than the capital G. So that is why it will return you false. If you write f greater than g, then it will return you true. Okay, because small g has a greater value than the capital G, right? So in this way it compares. Okay, so f is greater than h. What this will return? Please type what this will return. Okay, false. All right. Oh, everyone is correct. Okay. Let me do something interesting here. So, yeah, everyone is correct. So 0.1 plus 0.1 plus 0, 0.1, right? And I'm writing a double equal to 0.3. What this will return? True or false? So true, true, true. Sayak has also said true. Few people are not answering the things. Okay, Dev Rishi is typing. No, what he's saying. He's saying he's confused with true. Okay, so let's see the answer of this. It has returned false, right? So this is quite interesting. Fine. So so why I'm saying why it has returned false, because Python, what Python does, okay, it does some internal floating point approximation, right? So so 0.1 plus 0.1 plus 0.1, it was doing some approximation internally. So that value is not going to equal to 0.3, right? Let me show you, okay, why it is not equal. So if it does 0.1 plus 0.1 plus 0.1, right? And if you press enter key, you can see why it is not equal, right? So what I'm doing, I'm comparing with 0.3, but it is 0.3, and how many zeros are there? So many zeros are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 zeros are there, and then 4 is there. So just because of this approximation, right, which Python does internally, right? So this is not equal, right? So be cautious when this kind of questions are given, right? So you just remember my rules. Okay? Python internally does approximations of the floating point numbers. Okay, but if you write here print, if you write print 0.3, it will print 0.3, right? It will print 0.3. But if you perform some calculations, right, it does internally some approximation, right? If you write here 0.1 plus 0.1, so it's giving you the result 0.2, but it does some approximation internally when you do calculations, when you do more calculations, right? Okay, let me write it down so that you people can understand. So, notice Python returns false. Python returns false when you compare. When you compare. No, it's not like that. Python has some approximation codes executing behind, right? So for that reason, it is generating this value. You can see this value. This is very close to this value is this is very close. This is very close to 0.3, right? I think you have done limits in your class 11 and 12, right? So it follows that logic only. Okay, it's going to be very close to 0.3, but not exactly 0.3. In limits, you have done these kind of calculations. So same logic is implemented internally in Python, right? So your calculation is very going to be very close to 0.3, but not exactly 0.3. The people who took mathematics, they can easily understand uh, why this is false, right? So it implements, Python internally implements the limits logic, right? So that is how this 4 has came, right? So some internal calculations are going around, right? So notice Python returns false when you compare 0.1 plus 0.1 plus 0.1 equal to 0.3. Okay. So if you add these three, if these values were added, right? So you have got something like this, right? And this is very close to 0.3, right? So for this reason, right? So for this reason, for this reason, for this reason, the result is false. The result is false, right? So always be cautious when comparing floating point values, floating point values starting with starting with 0 point xxx 0 point 0 point xxx x starting with starting with 0 point xxx and x, right? So always be cautious, right? So never answer directly, use your brain and use my words. It uses the logic of limits. It uses the logic of limits, and it uses the logic of limits, right? So you use the logic of limits and then answer the question, right? And we can't see this code. You can download the Python source code from the Python's website, but it is very difficult where they have implemented this thing, right? So I didn't try it. You can give a try if you have time. So just I uses this logic whenever I am solving this kind of questions, right? Because we need to solve, we are not supposed to worry about how limits is being implemented inside Python, right? We have to worry about how to solve our own problems. Okay. So relational operators can be used with arithmetic operators also. So you can write a statement like this. Okay. So for example, I have declared few variables like earlier: a equal to 3, b equal to 13, p is equal to 3.0. So I can write here a plus b is greater than p, right? So the value of a is 3 and the value of b is 13 and the value of p is 3. So it will return you true. Sorry, is greater than p. So it will return you true because 3 plus 13 is 16. 16 is greater than 3.0. So you can use this kind of thing, right? In the with the relational operator, right? You can mix the expression with the arithmetic operators with the relational operator. So let me do one mixing here. So if I'm writing here a plus 5, a plus 5 is greater than the name of the variable is p. 5 is greater than p minus 2. What is the value? What will be the value for this? What will be the value for this? Type the answer. The value of a, we have took now a there. A is 3. Take these values into your copy. A, B, and P. I'm using that. So 5 greater than P is equal to 1. It is true, right? It is true. And it is written inside a bracket. So bracket bracket has the highest precedence as we have done mathematics. So the value will be what? Oh, he is saying the answer is 2. Let's see the answer. Answer is 2. No one is typing the answer. Everyone is confused. I think so. So 3 plus 1 is 4. 4 minus 2 is 2. Okay. So I got answer as 2. Let's see the answer here. It is 2, right? Because 5 is greater than p, so it will return you true, right? True means internally it is 1, right? The value of a is 3. So 3 plus 1 is 4. So 4 minus 2 is 2, right? So, so I'm giving you a 2 minutes break. Then after that, I will return back and I will teach you something called identity operators, and this is very much useful. Hello. The break is over, so you can join the class. So the next thing is the next concept is identity operators. So there are two identity operators in Python, right? The name of the first operator is, right? And the second operator is not, right? So this is operator is, and this is not, right? And the uses is also A is B. So this is how you can use it. Uses A is B. And we can write here A is not B. Fine. So this is the uses, right? So it returns true. So description. It returns true. It it returns true if both the operands are, if both the operands are pointing to the same object. If both the operands are pointing to the same object, to the same object, right? That is, that is both referring to the same memory location, both referring to the same memory location, memory location. Fine. Returns false otherwise. Returns false otherwise, right? So returns true, returns true if both its operand, both its operand true, if both its operands are pointing to different objects, are pointing to different different objects. that is both referring to, that is both that is both that is both referring to different memory location, different memory location, and returns false otherwise, returns false otherwise, right? So let me show you example. Say for example, I'm writing here, let me clear this out. Okay, so a is equal to 500. Let's use big values. 500. B is equal to 600. C is equal to 500. And then if I write here A is B, what it will return, please type. So according to theory, what it will return. So theory says that if if I've written here A is B, it returns true if both the operands are pointing to the same object. That is, both are referring to the same memory location. Returns false otherwise. Okay, so false. Two people are saying it is false. Then again false. So it is false actually because it's pointing to two different memory locations. All right. So if I'm pressing enter, it's returning me false because if you can see that the value of A is 500. So the value of A is 500. It's pointing to 500. The value of B is 600. And the value of C is equal to 500. That means C is pointing to 500, right? So if I'm writing here A is B, so this statement is false because both are pointing to different memory allocations. Both are pointing to different memory allocations. Memory allocations. Memory allocations. Fine. So let me give you more example. So we try. So you can use IDs also to know the memory locations. Type ID A, you can get the ID of A. If you type ID of B, you can get the ID of B. If you can type the ID of C, you can get the ID of C. So now you can see that the value of ID of A and the value of ID of B and the value of ID of C, right? Are all three are 816, 8416, and 8512. So C's ID is different, but let me check whether A is C or not. A is C or not. So it's returning me false because the ID of C is different here, right? I have written A equal to 500, B equal to 600, C is equal to 500. So when I'm writing here, A is C, then it's returning me false, right? because it has used, uh, I have written the same value. It should return, the IDs will be same for the C. Why it is different? That is what I was thinking. Let me redeclare it once. A, A, sorry, A equal to 500. B is equal to 600. C is equal to 500. Maybe I have given some space or something. I don't know. But it should be same. The IDs will be same. ID of A, ID of B, ID of B, this, okay, and ID of C. It's different. Oh, yeah, its memory location is different. Mm, okay, because the value is bigger, or I don't know what might be the reason. It should show the same thing. What is showing the different memory location? Let me type it once again. A is equal to 10. B is equal to 20. And C is equal to 10. So ID of A. So ID of A is this. ID of is this. Right. ID of C. 176. Okay. So if the value is small, it is working fine now. But I can take bigger values also, because according to theory, I can take big values. Now you can see the values. Now you can see the IDs, right? 2035546 is the ID of A, and you can see the ID of C. Both are same, right? So let me do one cross check with the Python. Okay, what is happening with the IDs? So we go there and we check. When ID in Python differs different. They are taking small numbers as an example, um, but for bigger number, I want to check it for big numbers. Take. Let me take leave the numerical examples if I perform search. Say for example, let me write here fruit, F R U I D fruit. No, there is not a problem of idle, right? That is not the problem of idle. Maybe the version is changed, right? So in that, it differs with version to version because Python, because I have spent all my life in Python version 2.0, right? And now I'm teaching Python 3.2.x. I've spent all my life, and now I'm teaching Python 3.x. So 3.x has some features which I have to go through, and after that I will update you. Definitely I will update you, right? So it's not the problem of idle, it's a problem of I tried bigger values on PyCharm. It is true even for the bigger values. Mm, I don't know about it, but it should work with the idle because it's a shell, Python shell I'm using it. So Python shell, PyCharm maybe depends upon it's not version. It's not about it's not exactly the which version you are using in maybe in 3.x in Python 3.x they are using some different terminologies which I have to go through, and basically I am teaching you with some updated knowledge regarding Python 3.x. So I have to go through in detail. And after that, I will update you. Definitely, I will update you about this. Okay. So don't worry about these things. So let me try with some string. Let me do some experiments. Fine. Yeah, yeah. It's giving different values, right? It's giving different values. Yeah, I have to read it, read the matter key, why now it is different. Okay. So I have to verify it first. So let me try with some different variables like fruit is equal to, say fruit 1 is a variable, and the name of the variable is apple, and fruit 2 mango, and fruit 3 is equal to apple. So let me try with the IDs of these variables. IDs of fruit 1. So you got the ID of the first variable, then ID of the second variable. Okay, and let me take the ID of third variable. So you can see the first variable ID and the third variable ID is same, right? So now if we apply here fruit one, fruit one is fruit three. It will return you true. Okay, because both the IDs are same, right? Both the IDs are same. So generally, it gives this is a logic basically. The logic which I have written, it's almost correct, but I don't know. There is something Python has embedded or like that. With some integer values, there might be some logic is implemented. So for that reason, for string, it is working fine. If you write fruit one is not fruit 2. This will return true because fruit 1 is not fruit 2. Okay. And if you write fruit 1 is fruit 2, then it will return you false. Is fruit 2, then it will return you false, right? So this is a concept, right, which I have written. So I'm not writing the integer concept over here. Maybe Python is allocating different values for the integer. I will do the research work regarding integers and I will definitely let you know by the next class. Okay, I will write it down. I will do the work on integers and floats maybe maybe the problem with the floats also, and then I will update you. Then I will update you. Date. Okay. So that might be the evenly. The concepts are same. This concept is implemented. It's same, right? The concept is same. So so now you can if you can change the value, right? So for smaller number, it's working fine. So because the main thing is that if you change the value of fruit 3 is equal to, so you are writing fruit 3, so you are writing here fruit 3 plus equal to, and again you are writing here apple, right? So now you can see the value of fruit, so it's apple, right? So now the value of fruit 3 is changed. Now if you check the ID of fruit 3 has changed its ID, right? So 63746375750, and here the ID of fruit 3 is 598. So now it has changed the IDE. It has changed the IDE. Okay. So, so now what will happen? If you compare, okay, if you write here, fruit fruit one is fruit 3. Fruit 1 is fruit 3. Fruit 1 is fruit 3. Okay. So it will return you false because the ID has changed, right? So if you are if we are using identity operator, it compares the ID. It will not compare the value, right? So this is what you have to keep it in your head. Okay. So it will not compare the value. Okay. So next thing is equality operator, which we are going to use, right? So the next thing is equality operator. Operator. Uh, is my screen is visible to everyone because my internet is fluctuating because of rain. So if you can see it properly, press yes. Okay. Okay, not a problem. So equality operator, which is double equal to, right? And identity operator and identity operator identity is operator. Identity is, right, important relation. Important relation. So the relation is when when the is operator when the is operator the is operator returns true for two variables for two variables. It implicitly it it implicitly means that equality operator will also return true. Operator also returns true. Fine. That is that. Yeah, that might be the reason, Swaptika. Right, but I have to see this because one person is saying that ki in his pie chart this is working, and in my shell it is not working. So I have to check it out. Right. So so when the operator returns true for two variables, it implicitly means that equality operator also returns true. Um, that is the expression. Expression. That is expression A is B as true as true that A double equal to B will also be true always. So let me do the experiment of this. So for example, say I am writing here, okay, A is equal to 200 and B is also equal to 200, right? And if I write here print A comma B, you can say see that ki both are printing 200 and 200, right? And when I'm writing here A is B, it's returning me true, and when I'm writing A double equal to B, it's returning me true. So it's working fine, right? Um, here now the next thing is, okay, but it is not always true, but it is not always true. Other way around. Other way around. So if equal to operator is giving you true, but when you are using is operator, it is giving you false, right? That means that means there are there are some cases where you will find where you will find that the two objects and the two objects are having just just the same value, same just the same value, that is that is that is equal to equal to operator returns true. Operator returns true. That is equal to operator returns true for them, for them, but the is operator, but the is operator returns false. Right? So where's my pen? True operator. Two objects having the same value equal to operator return true. This is operator, right? Returns false. Okay. So let me check this case. Say for example, I can use the value a is equal to 500. I'm using b is equal to 500. Right? Now I'm comparing a is b. It's going to return me false because both are separate objects. If you check the IDs, right, of A, if you check the ID of A and if you check the ID of B, right, so both are separate objects. Fine. So now if you compare A is B, then it will return you false. But if you write A double equal to B, it will return you true, right? So it's never work other way around. So never get confused with is operator and the double equal to operator. So that is why I'm investing time over here. So few people say, so this is working, but this is not working. And and Python is uh, very humble language. So people do loads of mistakes in Python, right? So that is why the development processes also halts in Python because of these silly mistakes, right? So Python, in that way, also Python is a very difficult language in that way because people do loads of silly mistakes and we are writing many lines of code, and if the conception is not clear, people will do loads of silly mistakes, and those mistakes hampers uh, time, right? So these kind of things are there, right? And you can see that when you are creating complex complex type of object, right? Complex is a data type in Python. So for example, if you are creating a complex, say for example, x is equal to say 2 plus, sorry, 2 plus 3.5 j. So this is one complex, and you can create y is equal to 2 plus 3.5 j, right? And you check the IDs of this complex data type, right? You will find that the IDs were different. The IDs were different. If you compare x is y, x, sorry, x is y, it will always give you false, right? And if you write here x double equal to y, it will give you true, right? So this is the best example of that. This is another example of that. So we can use this. This is another example. Okay. Got my point. And there is another thing that let me show you another way how the values are differ, right? Say for example, you declared a variable here k is equal to 3.172, and then you have written here L is equal to float, and you're trying to input, and you are entering here enter value. So I'm taking the data from the user. So whenever you take the data from the user, it always allocates a new memory allocation, right? Whether it is a short value or it's a long value. So I have entered it, and now if you type the ID of k, it is a smaller value, but if you type the ID of K and ID of L, you will find that both the IDs are different, right? But they both are containing the same value. So if you write here K double equal to L, it will work, right? It will show you true. But if you write K is L, it will return you false, right? So whenever you take user input, it always occupies a new memory allocation, right? So this is another example. So yeah. So so here you write it down a small note here. Note is when we are taking any user input, any user input, right? Python always, Python always, always allocate, allocate or point to different memory allocation, different memory allocation, allocation. Fine. So I hope you people have understood the relationship between is and equal to operator, right? So next week, I will be teaching you some very much interesting concept, and I will definitely do the research work of that thing also. And next week, I will be teaching you logical operators, right? Logical operators. And there are some interesting facts in Python, which is not there in C, C++ or in Java in logical operators, right? It's very much interesting. And because Python is, people always say that Python codes are like poetry. So you need to understand the internals of Python, right? So so that's the thing. You need to understand. If you don't understand the internals of the Python, so understanding of the existing code is going to be very difficult for a programmer, right? So that is why Python programming is in demand, and you will get a very good salary if you know it properly, right? Because companies have very less amount of time and they want more outputs from you people. So for that reason, Python codes, looking at the Python codes, it's look like, array, it's like a English, anyone can do it, but it's not like that. There is so much of internal things, right? People don't know. Okay, so you should understand the internal part of Python. So I will teach you every internal part. Okay, evenly the few school students have also joined over here. They are also enjoying it, but I'm teaching you few things which is not there in their syllabus also. Okay, so it's fun for them. They are getting something extra. Okay, so I'm closing the class for today, and the next day I will be teaching you logical operators, and it's very much interesting how logical operators can be used in Python, right? Then I will be teaching you bitwise operator. Then I will teach you the operators precedence. Okay, what will be the ordering of the operators in an expression. Then I will teach you associativity of the operators, right? When you perform calculations, how the operands and operators are associated. They are associated left to right or right to left. This part. So this will be, I think so this will be covered in, and then I will teach you, I will give you some idea regarding expressions also, right? Expressions and how implicit conversion takes place inside Python uh, in numerical data types, right? So that I will teach you. Fine. So there are loads of concepts in Python, basic conception. If your basic conception or foundation is clear, then you can easily understand the Python code, right? So very few people in the market having basic conception clear. They always focus on big codes and their basic conceptions are not clear and they always keep on struggling, right? And then after struggling, they feel that this language is also useless, right? Yeah, Devrushi has updated me with a photograph that here it is also working. So he has written the code a. But Devrushi, this is your program, right? Uh, I'm right now. I'm teaching a Python shell, right? Shell basically in program what happens now? Okay, in program, uh, uh, let me show you. In program, uh, let me show you. New file. Let me write it here. So A is equal to, say I've used this values 500, B is equal to 600, C is equal to 500, right? And if I'm writing here, print A is C. So let me save this. So I'm saving it here. Say test uh, dot py. Save. So it's saved in my computer and let me execute this. It's returning me true, right? So Python program is different and here it's returning true, right? And Python shell is different. Okay, I will come to the programming part, right? Currently I'm teaching you Python shell. Okay, so because in Python shell is also very much Python shell is also very much powerful thing, right? So I just want to uh, do with the Python shell. Okay, so in PyCharm you can write computer programs. Right, PyCharm is an IDE where you can write computer programs. Okay, so I will do the research work, Devrushi. Don't worry. There are some changes in every version. So as a teacher or as a professional, you have to be update yourself. It's my fault that I have not done the study properly before teaching it because I didn't got time. That is another thing. But I have to do the study. Okay, and I have to do the homeworks also. Okay. So anyhow, whenever you do some work, you will get some problems and you need to solve those problems in your life. Fine. Uh, don't you don't think that okay, I'm not able to do it in the front of them and what will happen to me? Fine. So what you have to do, you have to uh, understand the error. So this error has happened and you will try to find out the reason and come up with the studies, right? So that is what you have to do in your life. Okay. So in Python program, this will work definitely. It will work. Okay. But it will not work in Python shell. So I'm teaching you Python shell, how to use Python shell. If you are good in using Python shell, then Python program is not going to be matter. Okay. Chalo then bye bye for today, and the video will be uploaded on the YouTube, and the people who are members over here, they can get it over here, and you can invite your friends also on to join on every Sunday at 6 p.m. Okay, chalo then bye bye.